one key skill in M1 is to be able to cope with objects on slopes. Now this has a mass of 10 kilograms, which means it's got a weight acting downwards of 10 g, 10 times gravity. But this object stays on the slope because of what's called a normal reaction force, which is perpendicular to the slope, i.e. right angles. So these are the only forces acting, assuming there's no friction or no air resistance. So we've now labelled the forces acting. Now then, to find R, we have to do one important step, which is to resolve the weight into two components. One down the slope and the other into the slope. And this is how you always start off approaching an object on the slope question. Now this angle here is 40, so this angle here is 50, so therefore this angle here is also 40. And you always get that, the angle there being the same as that one there. So that's our angle. So we can resolve this 10g into components, one adjacent the angle and one opposite the angle. So this will be 10g cos 40, and this will be 10g sin 40. Adjacent is cos, opposite is sin. Now, because this object stays on the slope, these two forces here must cancel out. So R must equal the 10g cos 40 component of the weight into the slope. So R must equal 10g cos 40, which if we work out is 75.1 newtons. So in terms of motion away from the slope, the object is in equilibrium. So therefore those two forces cancel out. But there's this weight acting down the slope, and that causes acceleration down the slope. Now we know that resultant force equals ma. So this 10g sin 40 creates an acceleration. The mass is 10, so a is unknown, so a must equal 10g sin 40 all over 10, which if you work it out equals 6.3 meters per second squared. So again, the key step with any slope question is to resolve the weight into the components. One into the slope, the other one down the slope. This one is used to find the reaction force, and this one here is what contributes towards the acceleration, in this case down the slope.